All right, welcome in math class. All right, so in this video, I'm going to introduce how I expect your composition notes to be done. So here you can see I have an illustration. This is supposed to be an illustration of your composition notebook that I got right here. Okay, and on the front, you're going to have Math 2020 notes, and you're going to write your name here. So, for example, my name is Jake Shaheen, so I'll put Jake Shaheen. All right. Now, once you've got your title page or your cover set up, we're going to open the book. We're going to open your composition to the very first page, and we are going to open up by creating a table of content. All right, so at the top, you write 2020 Math Notes, table of content. That'll be on the very first page. In this top right corner, you'll have the page number, and we'll have a list going down here. You don't need this. We're going to skip 3 pages from this. So from here, I want you to skip 3 pages, and for 6th grade, this is going to be your first page of notes. So what you're going to do is you're going to come up at the top right here. You're going to put a nice little 1 right here in the top right corner, and that's going to tell you that this is page 1. So you've skipped 3 pages, and this is going to be your first set of notes right here. So we're going to come back to the table of contents. So the first page of notes I have for you is division and fractions. So everybody's first page should be like division and fractions. And like I said, well, as I mentioned, your handwriting's not going to be the same as mine. So some of y'all will be able to fit all of these notes onto one page. Some of you won't. Some of you will be able to fit more. Some of you will fit less. So from here, after this, it's going to diverge, right? Your page 2 is not going to be the same as my page 2, likely. So yeah, just keep that in mind. And we're going to use front and backs on these papers, okay? So from here, let me give you a explanation of what's on these notes. All right, welcome in. These are your notes for 6th grade. These are the first set of notes that I'm giving you to copy. So I left a picture of these, so if you don't want to talk about it, if you don't want to hear me discuss it as you're copying, then you don't need to watch this video. But I just figured I'd give sort of a synopsis of what's happening in these notes right here as you're copying them, right? So our first set of notes here is over division and fractions. And we're going to be dividing by fractions. So these notes are for 6th grade specifically, although I'll probably use them in other classes, so get ready for that. But from 6th grade, Module 2, we're dividing fractions, so I figured I'd give y'all some notes on division and fractions. So the first part here says division problems can be written in multiple forms. You've all seen these forms before. They have this one right here, the little dot, dot, dot one. I don't know if y'all can see my cursor when I'm doing this, when I'm recording. Anyway, you see the one with the 2 little lines, the one with the little house, maybe you called it a house before. And then we have this little backslash right here. Oh gosh. Wait, can I? Hold up. Oh God. Don't do that. Oh no. Anyway, sometimes you're going to see it written with the fraction bar like this, okay? And then here you see in the last example, we have an actual fraction, 8 over 4. And again, a fraction is just a division problem. So you have 8 over 4, well, that's 8 divided by 4, which is 2, right? Fantastic. So a simpler form of that is 2. Parts of a division problem include the dividend, divisor, and quotient. And I have an example right here from the example we have up top, right? So 8 is your dividend. That is the number you are dividing up. 4 is your divisor. That is the number of groups you want to divide 8 into. And your quotient 2 represents your answer, essentially. Your quotient is your solution. I wrote quotient really bad down here, but you can see where it is right here. Okay, your quotient is the solution to a division problem. And it represents the number of groups you get after you break a dividend down into a certain number of groups. So take some time, finish copying those notes right there, and all right, so continuing a discussion of fractions. Fractions, we use a fraction bar to denote a fraction either one of these two ways. Either one of these examples. We use a fraction bar to denote a fraction either one of these ways. Yeah, that's what that's supposed to. Either one of these ways is the way we write a fraction, right? 1 over 2, 1 over half. Y'all are gonna be okay. If you see that, you know. You can figure that out. You're gonna be all right. These are two ways you can write a fraction: 1 over 2, or you can use the slash. Okay, both of those represent fractions. A fraction represents parts of a whole, where your numerator is the top part, your denominator is the second part, and your numerator represents the number of parts of the portion, and your denominator writes the number of parts in the whole. Anyway, you got some to copy these notes. It makes sense. When the numerator is larger than the denominator, this is known as an improper fraction, and we talked about this in the lessons. And you've seen this by now. When the number on the top is bigger than the number on the bottom, that's called an improper fraction. It's improper for the larger one to be on top. So this means, in our example here, this means that there are 10 of 5 parts of one whole. So since we have 10 of 5 parts, that means we have 2 wholes. And I probably could have saved myself from some effort by just having the last little bit of this in the frame. But just a reminder that a fraction is also a division problem. So 10 over 5 is equal to 10 divided by 5, which is equal to 2. So 10 over 5 is equal to 2. I apologize. Oh my goodness. So finish taking these notes. You can pause it here if you haven't finished. And okay. All right, continuing your notes on fractions, we'll continue by taking notes on improper fractions and mixed numbers. So some of you may know that these are essentially one and the same. When a numerator is larger than and is not a multiple of its denominator, we can represent that fraction as a mixed number. And I have my example down here. You have 11 over 4, which can be rewritten as 2 over 3/4, and I showed you how I worked that out. Y'all have done remainders in division before, right? So 4 goes into 11 twice, 2 whole times. 2 times 4 is 8, so you take that away from 11, and you have 3 left over. You have 3 as your remainder, so that goes into our remainder, R. So 2 wholes, 3 is a remainder, and we rewrite that as 2 wholes with 3 of 4 parts. 4 was our denominator in the original improper fraction. It stays our denominator. That doesn't change. So the denominator 4 goes into 11 twice with 3 as the remainder. So 3 stays in the numerator. We have 2 wholes and 3/4 of 1 whole. Take your time taking those notes. I should really think about how I'm showing these. I'm blowing up the screen so you can see it if you're watching the video, so you can see it a little bit better. But anyway, the only thing that's different in this part is right below that last bit of notes we got. In our example, 2 over 3/4 is equal to 2 plus 3/4. So we have 2 and 3/4. I just wanted to explain that because we're going to go into how to write mixed numbers into improper fractions, which hopefully, I'm just going to keep this live. Anyway, let's see if we can get this in the frame that I want this in. I need to make it smaller. Oh God. Okay. Everybody's proud of you, Jake. Keep going. family loves you. Okay. Perfect. All right. So, from mixed numbers to improper fractions. Example. So, let's say we take our 2 3/4 and we wanted to turn that into an improper fraction. Well, we would add 2 plus 3/4. Remember that that's all that 2 3/4 is, right? 2 3/4 equals 2 plus 3/4. So we have 2 wholes plus 3/4. Now we can rewrite 2 wholes as 2 over 1. And then remember, we can rewrite 2 over 1 as an equivalent fraction by multiplying it by 4 over 4, giving us 8 over 4. Now that these fractions have common denominators, we can add them together. What did I do right here? Okay, whatever. Now that they have common denominators, we can add the numerators. 8 plus 3 is 11 fourths, and you go back and look. That's where we came from, right? That was the original improper fraction. We turned it into the mixed number 2 3/4. And look right here. There's a cheat code. So this cheat code is kind of like the shortcut to all of this. So if you want to, all you need to do is take the whole number on the outside, multiply it times the denominator, and add that to the numerator. So 2 times 4 is 8. You add that to 3, you get 11 over what? Why did I have times 2 down here? What was that about? Times 2. Oh, yeah, that's right. 11, 4 times 2 is 8. So we added the 8 up here. We got 11. The denominator stays the same, so it's 11 and a fourth, okay? Now, so these rules that I have over here, these are rules of math. You will write them, okay? And I like the way I wrote it next to these. So let me go through these. So first, any number can be written as a fraction or can be a fraction, yeah? So in this example right here, you see the little circle where it says 1 right there on rules at work over here. It has 1, and this is the example. So any number can be written as fraction. 2 can be written as 2 over 1, yeah? Every fraction has an infinite number. This is what this little sideways 8 means, right? If you haven't seen that before, that's infinite. So there is an infinite number of equivalent fractions for any fraction. So you can rewrite numbers a million different, like an infinite number of ways using fractions. Okay, and that's what we did in this step right here. We change 2 over 1 by multiplying it by 4 over 4. Remember, 4 over 4 is just 1. 4 over 4 is 4 divided by 4, which is 1. It doesn't change the value of 2 over 1. It's still 2. 8 over 4 is 8 divided by 4, which is 2, right? 2 over 1 is 2 divided by 1, which is 2. So we didn't change it from these steps. We just made it an equivalent fraction. Rule 3, any number multiplied by 1, that number 1x, 1 times a equals a. Yeah, right. This is one you've learned a million times. Any number multiplied by 1 is equal to that number, okay? You multiply 1 times 100 million, and it's that number, right? And that's why we were able to multiply this by 4 over 1 without changing its value. I mean 4 over 4 without changing its value, because 4 over 4 is equal to 1. So it didn't change anything, okay? Rule 4, we can only add fractions with similar denominators, and that's where we get to right here. When we're adding these fractions together, we have 8 over 4, 3 over 4, add the numerators, and there you go, you get 11 over 4, right? Okay, so for down here for the cheat code I wrote, take you take the whole number. So when you're turning improper fractions, the mixed numbers into improper fractions, take the whole number. In this case, it was 2. You multiply that by the denominator, which in this case was 4. You add the product to the numerator. That was 3. So you add 3 plus 8. Maintain the denominator. So 11 over 4. If you're not familiar with how to do mixed numbers, we need to do practice on you. We need to be able to do this. We're going to be messing with fractions a lot in middle school and for the rest of your life probably. Your whole life is just going to be a fraction of a second. in the cosmic scheme of things. So take your time, take these notes, and we'll come back. All right, this is the last set of notes for you for this week's lessons or whatever. Anyway, so in this set of notes we're going to be continuing a discussion of fractions and division and dividing fractions, but we're going to start by multiplying fractions, right? So top we have multiplying fractions. When you multiply fractions, we multiply numerators with numerators, denominators with denominators. And I give you an example. So 2 times 3. All right, so first of all, remember, we can rewrite 2 and 3 as a fraction. The easiest way to do that is to just put it over 1. So we have 2 over 1 times 3 over 1. All right, so we're going to multiply the numerators with the numerators. So in the numerators, we have 2 and 3. We multiply 2 times 3. In the denominator, we have 1, so we have 1 times 1. So we have 2 times 3 in the numerator, that's 6. 1 times 1 in the denominator, that's 1. 6 over 1, or just 6. Now, it looks really complicated, but remember, we start off as 2 times 3, and I bet most of y'all know what 2 times 3 is. It's 6. So I'm just demonstrating that using fractions. Now, or you can have this example right here, 3 over 5 times 3 over 4. And here we're again multiplying numerators times numerators, denominators times denominators. So 3 times 3 is 9, 5 times 4 is 20. So, yeah, that's multiplying fractions. If you hadn't been taught that before, there you go. That's how we do it. Great. Take those notes, take your time. Pause if you need to. I'm going to continue this video. I'm just going to come down to dividing fractions. Yes. Okay. I can't. Great, Jake. You're really doing it, man. Your family loves you. Good job. I'm proud of you. Okay. All right. So dividing fractions. When dividing, we take the reciprocal of the divisor and multiply with the dividend. So that sounds complicated, okay? And I haven't given you a definition for reciprocal yet, but I will. I'm going to give it to you right after this. So don't worry about that just yet. But we have some examples of how to divide fractions. So again, I'll start off with a whole number example. We have 4 divided by 2, which is going to get you 2, right? And most of y'all already know that. 4 divided by 2 is 2. So you can see that at the end here, we get the 2. But let me show you that in fraction form. So we have 4 over 1, right? We can rewrite 4 as 4 over 1, divided by 2 over 1, just rewrote 2, which equals, and now when you divide, you take the reciprocal. Now look, you'll see I have a drawing between 2 over 1 and 1 over 2. Those are reciprocals. Look what happened. You see what happened? All that happened was I flippy-floppied the numerator and denominator, okay? Now I do this with the divisor. So you flippy-floppy, you take the reciprocal of the divisor. That's the part you're dividing by. So we took the reciprocal and now we're multiplying. Remember that is multiplication. So we multiply numerators times numerators. 4 times 1, 4. 1 times 2, which is 2. So we get a fraction as 4 over 2. Well, we know that's just a division problem. 4 divided by 2 is 2, right? So but 2 is equal to 4 over 2. So it's just another way to write it. And down here I have another example using regular fractions. Again, something you might be more comfortable saying. 3/5 divided by 4/5. And that's going to be equal to 3/5 times 5/4. So what you'll see here again, I have the 2 lines connecting the arrows. These numbers are reciprocal. They are reciprocal to one another. So we flippy-floppy the divisor and we multiplied. So we're going to get equals 3 times 5 in the numerator, which is 15, 5 times 4 in the denominator, which is 20. And then we can simplify this by dividing both parts by 5 to get us 3 over 4, okay? And we talked about that in the lesson 1 for 6th grade, or it was lesson 3, module 2, lesson 3 for 6th grade. That when you have common denominators, all you're doing is putting the numerator for the dividend keep it that, and then take the numerator for the divisor and putting that in the bottom, which is what we came out with, 3/4. All right, so don't freak out. Take these notes. Pause it if you need to. And I'm gonna scroll down. And the last part of these notes, I should have left myself some more space on this particular page, but that's fine. We're going to be talking about reciprocals, reciprocal or multiplicative inverse. So a reciprocal is a multiplicative inverse, and what that is any pair of numbers whose product is 1. So what do I mean when I say product? What operation is happening when I say product? That's multiplication. So any two numbers that when you multiply them together, you get 1. All right, so our example here, we have 2 and 1/2. Okay, let's just start with that example. So we multiply 2 times 1/2, we get 2 over 1 times 1 over 2, which is 2 times 1 over 1 times 2, which is just 2 over 2. It's a little bit, it's explained. You get it. And then 2 over 2 equals 1. So when we multiplied 2 times 1/2, we got 1. So they are reciprocals of one another, multiplicative inverse of one another. And in the next example, I have a more common fraction, 3/5, and its reciprocal 5/3. You'll see that the numbers are just flippy-floppied, right? So now when we multiply, we have 3 times 5, which is 15, and 5 times 3, which is 15. Well, 15 divided by 15 is 1. So the numerator here, down here with the stars, I have just sort of a cheat code for you to look at. When the numerator and denominator switch places, that's a reciprocal. Okay. When I say take the reciprocal, all you do is flip that fraction on its head. Okay. You flip them. You flippy dippy. Okay. All right. All right. We'll be back in another video with some more notes. Pause it if you need to. Bye.